Alright, welcome to Math 101. Today we are looking at simultaneous equation. So simultaneous equation, just as the name implies, you are solving two or more equations together or simultaneously, right? But mostly it's two equations. And why do we have two equations? Well, from linear and other equations, right, we just have one variable, let's say x, or only y that we want to find, right? So it's easier to solve that equation alone. But in some cases, you have two, say x and y, all in the same equation. In some instances, it's difficult to find the value of what both variables unless values of variables. What happens? You'll be given two equations with variables. So, example, I have 2x. Hope you can plus 3y equals to 2. So let me name this my equation. And then I can have 3x plus what? 4y to 20. This is my second equation. All right. So you can see I have x and y in equation 1. And then also x and y in equation. If I take only one of such equations, for me to solve for the both variables. So what I'm going to do is I'm going to solve the two equations simultaneously. And there are two methods by which we can solve this. The first method is the elimination method. Elimination method. Well, what's the elimination method? So the elimination method is saying that because it's difficult for you to deal with the two variables at the same time, eliminate or remove one variable from the equation so that you can solve for the other variable and now come find what the variable eliminated. So let's look at how that works. Well, we can choose to eliminate x or from what the equation, right? We can choose either x or y, and what you choose to eliminate on you. There are some few tricks that helps you, makes it easier for you to eliminate. So what are the things that makes it easier? Well, you look at the coefficients, right? So you look at the coefficients. I mean, when I say the coefficient, the number standing before the. So you look at the coefficient. X is 2, here is 4. When coefficients are the same, it becomes easy, right? Or it's what? It's over here, it's not the same, 2, and then we have 3. What do you do in some instance? You make sure that what the coefficients are the same. So you then have to make sure that the coefficients are the same. So what do? You find out, you ask yourself, can I use a number to multiply this equation, right? Such that when I multiply this, the coefficient of this will be the same as this, right? If it's possible, then you do it that way. For instance, if here is 4 and here is 2, I can multiply this equation by what? 2, and then this becomes 4. So 4 and 4, easy for me to eliminate. But in this case, that's not it. We can't multiply this place by a number to have this to be the same as this. Neither can we multiply this, side by a number to make sure this is the same as this. The same applies to the y. So what do we do? In such an instance, what you do is you use the coefficient of this x in the equation 2 to multiply the whole of equation 1. So let me do that and let's see what happens. So I have what equation what? So what did I say? I'm using the coefficient of x here to multiply the whole of equation 1. So equation 1 times 3. What does it give me? 3 times 2x, 6x, plus 3 times 3y, that's 9y, equals to 3 times 12, that is 36. I can name this as my third equation, equation 3, right? Okay, so now I come to the equation. So I have the coefficient of x here to be 6, but then the coefficient of x in equation 2 is 3. I still don't have them to be the same. So what do? Well, I take equation 2 and then what? Multiply it by the coefficient of x which I had in equation 1. So that's by 2, right? And I have 6x plus 4y times 2, that's 8y, equals to 20 times 2, that's 40, right? I name that as my equation 4. All right, so what do I do next? Now I can see that the coefficient of x in both equations is 6, so it becomes easier for me to eliminate. Now, once you have the coefficients to be the same, what do? You check for the signs. If one of the signs is negative and the other is positive, you know that negative plus positive, if the coefficient is the same, will give you 0. And that's what you are looking for. You are taking the x away. But if the signs are not the same, the only way to get them to be 0 is what? To subtract. So I'll take one of the equations and subtract the other from it. In this case, I can choose to take equation 3 and subtract equation 4 from it. Why am I saying that? Because I want my y to be positive. It doesn't really matter though, because subtraction, you can always divide and then get your answer. So let me take equation 3 and subtract equation 4 from it. I have 6s minus 6s, that's 0. 9y minus 8y, that's y, equals to 36 minus 40, that's negative 4. So I know y equals to 4, right? Okay, good. Now the next thing is for me to find what my x is. So how do I find x? Well, I know the value of y to be 4, so I can take y and put it in one of the equations. Now, I have equation 1, equation 2, equation 3, and equation 4. But I want an equation that, it will be easier for me to solve. So it's always good to put it back in your original equations. That's either 1 or 2. Because you see 3 and 4, you have bigger numbers that you have to deal with and all that. So I prefer putting it back into either of the equations. Well, let me just choose equation 1. So substitute or put, right, y equals to negative 4 into equation 1, right? Okay, so now what do I have? I have 2x plus 3, y is now negative 4, right, equals to 12. So I have 2x, this is negative 12, equals to 12. That's fine, right? So I have 2x equals to, I'm sending this 12 here to go and it's negative, it will add to this 12, giving me 24. I want to find x, so I'll divide through by the coefficient of x. So I have x being 12, right? So that's the value of x. Now the thing about simultaneous equation is that you are saying that is this value of x, right, and then this value of y that satisfies these two equations. So if you want to confirm your answer, just put x and y into any of the equations, any of the 4. But always it's good to put it in the original because it makes your work easier. And when you put them here, it should give you this answer that tells you that it satisfies the equation. Let's try this quickly. So I put 12 into this. So this that's the end of the work though. But then I just want to make sure that you get it. So let's put x equals to 12 here. So I have 2 times 12 plus 3 times y is negative 4, right? Let's see whether it gives us this answer here. So this is 24. This is negative 12. The answer is 12. That's the answer you have here. So that's the elimination method of solving a simultaneous equation. I hope that makes sense. So basically, you make sure that the coefficients are the same, and here they weren't the same. So we use the coefficient of x here because we wanted to eliminate x. We use the coefficient of x here to multiply equation 1, and then we use the coefficient of x here to multiply equation 2, and we had this. Now the coefficients were the same, right? And so we eliminate y by x by subtracting the two equations, and we realize that y was negative 4. We put it back into either of the equations, these equations, and then we get x equals to 2. So that's basically the elimination method.